Hello everyone and welcome back. So in this video I'm going to be showing you guys how far I've got to making my Space Invaders clone using Python and Pygame. So this is the third episode in the series. So if you're new, I recommend that you guys should check out the first video where I'll be introducing what I've been doing in the series and how I've been doing what I'm going to be doing. So in this video I'm going to show you guys what I've done since the last one. So in the last video we implemented a basic laser shooting mechanic, so I can shoot lasers and then I can register whenever the laser's gone off the screen. Then I can make it so that the player can shoot the laser again. In this video I started building up upon those mechanics, and now I've got a working collision detection system. And as well as that, I've also made it so we have an enemy on the screen, and the enemy's moving right and left. So to illustrate this, I'm just going to run the program, so to make it easier for me to explain it. So here, the first thing you probably notice is that all the different players on the screen, or sprites, whatever you want to call them, they all have rectangles around them. The main reason I put rectangles is because I'm going to be using rectangles to do all the collision detection in this game. I'm probably going to change this to use Pygame's masks, which is going to allow me to have perfect pixel collision. So right now, as you can see, so as the laser's been shot, the laser actually has not touched the laser's picture has not touched the enemy's picture, but there still was Pygame still registered it as there was a collision being taken place, and the reason is because the space between the rectangle of the player has intersected with the enemy's rectangle, which makes it so that it will register the collision even though there has not been any collision between the actual pictures. So this can be troublesome whenever you've got multiple enemies, since the laser could just shoot one enemy. Well, the laser only hit one enemy. However, the rectangle of the laser is going to intersect with two enemies, for example. Then that would mean that both of the enemies are gone, and that won't really work out properly. So I'm probably going to change this to use masks, and if I do continue to use rectangles, then I'm going to remove these rectangles here, just to make sure that the collision is actually working properly, and so I can see the rectangles hitting each other. As well as this, I've also made an enemy at the top of the screen which moves right and left, and whenever it hits one side it moves to the other. I'm going to make it move down a bit later, because it took me quite a bit of time to make it go right and left and detect whenever it's hit one of the sides of the screen. And it won't be that hard to make it go down, so that whenever the enemy hits one of the sides of the screen it goes a little bit lower. Then it's going to keep on doing that until it gets to the bottom of the screen, and if the player has not hit it yet, it will just go off the screen once it's hit the bottom, and the player is probably going to lose some sort of life or a few parts of his score, or whatever it is. So I think I'll just get started. As well as this, in the output of this, when I was running this file, you probably noticed it said collision has taken place. This is just detecting whenever the laser and the enemy, the rectangles have intersected with each other, and then it was just notifying me saying that collision has taken place, because I told it to print that out whenever it's happened. I'll probably change it so that it removes the enemy from the screen once the laser has touched it. So the main difference between these, since the project since the last video in terms of code, is going to have started working on the ships. I implemented a ship class, which I put in the ship file. So here I'm just importing Pygame, and I'm also going to be importing random. So this ship class contains the code for how the player and the enemies are going to move, and how I can. And I put the players and enemies purposefully in the exact same class, because it makes it easier for me to detect between collisions. Because in the last video, the player was inside of this main class. Now I moved over to ship class, so it's just gonna be easier for me to work with the enemy and the player. So here I'm importing Pygame, and then I'm also importing random. The reason I'm putting random is that once I have multiple enemies on the screen, I can't have them all just spawning the same place one after each other. This can look unnatural, and it's not going to be staying true to the normal arcade game, which is Space Invaders. So I'm going to make it have I'm going to make it spawn in random positions at the top of the screen, and then I'm going to make them move down and left and right that way. So I have this ship class, and I've also imported everything from the main file. So in this main file, the only thing I really have is this class called main, and then it's importing sys and some other stuff. So I'm using main to be the parent class of this child class, which is going to be ship. And the main reason is because I want to be able to access some of the different I'll be able to access some of the different instance attributes which I put inside of the main class, like the screen and the screen's X and the screen's Y. So here, and then some of the enemies lasers and the how they look like, and then some of these colors here for this color the dictionary made called self.colors. I use some of the colors in there to draw the rectangles, the color of rectangles outlined there, and that's the main reason I wanted to use that. So here, in the initialization dunder method, or is it constructor method? It's one of those two. So the actual name of this is going to be the constructor method. So here I'm going to be passing in 3 parameters, which is going to the ship's X position, the Y position, and the image of the ship. So I'm going to create a new instance of the ship class whenever I have a new ship which I want to draw on the screen. And then I'm also inheriting all the instance attributes from the constructor class called main, and I try to keep all the instance attributes in the constructor class because I'm gonna need all the ones which are here. So I'm setting the enemy's X position to be equal to ship X. I'll probably just get rid of ship X and then set it to the value by default, because I wanted to have a random value, and then having to make an instance of this class every single time, and then having to set it manually is probably just gonna not really work out. So I'll probably set enemy X to be something like random.randint, and it's gonna be between like 0 and then self.screen_x or whatever it is. Right now I'm just going to keep it to this. I'm going to change in the future. And then the enemy's Y position. So in Pygame, the screen's essentially made up of 2 parts. So if I just quickly show a picture. So the screen's here, and then the screen's X is going to be, the screen's Y is going to be there, then the X is going to be here. Okay. So the Y is here. So the thing is, in Pygame, this top part, oops, I was supposed to draw this here, and then this one's gonna be there. Okay, so in normal screen, you're probably gonna be noticing that the X axis is gonna be up here. Usually it's down here, but in Pygame, the center or the starting point of the entire screen is gonna be here, which is 0, 0. I'm probably just going to make this a bit bigger so you guys can see. Okay. That's 0, 0, and then here's whatever. This is going to be your Y position. So the lower down you go, the higher the Y gets, and the further you go from the X, the higher the X gets. Usually you'll notice that, well, the further down you go, the less the Y value is going to be. But in Pygame, since the origin point's here, is actually just going to be going down this way. So let's just say my screen is 600 by 600 pixels. This will be 600 pixels, and this will be 600 pixels for the Y position. And for that reason, whenever I go down, this is going to be increasing. But however, if the x-axis was somewhere around here, and then this is going to be origin point here 0, 0, then whenever I go up, the Y position will also be getting higher. So if I just remove this, so that's what that one is. So the enemy's X and Y, so I can draw it properly on the screen. Then you also have the enemy image. So since I'm probably gonna have multiple enemies on the screen, I made them have different images. So if I go here, we've got the enemy blue ship, the enemy green ship, the blue ship. I'm just gonna be using those images to make the enemies, and then I'm also going to be having these two, which is enemy move X and enemy move Y. So whenever I run this file, this enemy is moving 2 pixels to the right constantly, and then it's going to be moving 2 pixels to the left once it hits that side. And then I'm also going to make him move 20 pixels down whenever it hits one of the sides of the screen. So that's why I put this enemy move Y there. And then also I put this variable here saying enemy off screen. So this won't really make sense for now, but it's mainly just used around here to make so that the enemy moves right and left across the screen. But right now that's not. I'm gonna get into that a bit later. So here's the first part. So I'm drawing the enemy ship. So okay, this is a quick comment. So what's happening right now is that I set the enemy ship to be 50 pixels by 50 pixels wide, and depending on how big your screen is, that might be a bit too small, so I might just make it so that you can make it a bit bigger if you guys want to. So here's the enemy ship. So I'm going to be drawing the enemy ship here, so enemy image, and then what I'm also going to be is I'm going to put a self to enemy X and self to enemy Y, and then as well as this I'm going to be doing. Sorry, I think I probably got a bit confused here. I don't know why I wrote this comment. It's probably not because I want. So you guys can ignore this comment for now. I think I accidentally wrote it at some part earlier when I was doing the coding part. So here we got the enemy rectangle. So this enemy image, I'm just getting the rectangle, and then I'm going to be getting the top left of it. So in Pygame, if I quickly open up Paint again, so let's just say my enemy is going to be this square here. Well, it's going to have a few properties. So this point here is going to be the center. And also this part here is going to be the top right. The top left. And then this here is going to be the top right. And this here is going to be the bottom. And then bottom right. And this is going to be the bottom left. There's also going to be some others between there and those ones. But this is the general part. So I'm telling Pygame to get the top left position of it here. So it's going to get this part of the image as a rectangle. So that's where it's going to be doing that. And then as well as this, so this is one of the optional parameters you can put into it. If you go into the Pygame documentation, there's a bunch of other ones you can use as well. So this is just one of them which I needed to use to make the enemy ship actually look the way I wanted to. If I remove this, then I'll show you guys how it looks like by default. It looks like this. So the rectangle will not follow the enemy ship, it won't update its position, and by telling it to move to the top left, I'm just going to make sure that it does it from that certain point. It keeps on updating it that way. So if I change to something at the top right, which I showed you guys about before, say I do top right, and then I go back into my Space Invaders game. As you can see, it's there, and that's because it's calculating. Pygame always calculates the point from here, so the origin point. So the origin point of the screen's 0, 0 here, which is the top. This is the top left. So the sprites also have the origin point to be 0, 0, which is going to be the top left right here. So telling it to make the rectangle from the top left here will make it will work properly. And that's what that was for. Then I'm also drawing the rectangle onto the screen so I can actually see the rectangle as it moves across the screen. I'm probably just going to remove this afterwards, but this is just so I can visualize and make sure that the collision detection system is actually working properly, and is actually those two rectangles actually they're colliding with each other. And then I made this one as color green, and then I also put down an outline of 1 pixel. You can change this to 3 to make the outline a bit thicker. And as you can see, the lines around it is a bit thicker. I put it to 1 because it just seems to be a bit easier. Then as well as this, I also call this function called enemy ship movement, which makes the enemy move. So if I go right here, so what's the parameter it's going to be taking is going to be the enemy rectangle. The reason I'm calling the enemy rectangle here is because this enemy rectangle, this instance attribute has not been defined inside of the constructor method, so I can't really reference to it from there until this method is called. So I call this down here and then pass this as an optional as the optional parameter, so that I could use it. Otherwise, it's going to give me an error saying that software enemy vector does not exist. So if you're asking why I don't just put it here, so software enemy rect and put it to be that, the main reason is because for some reason it did not work like that, and then it didn't really update the player's rectangle whenever I did it that way. So if I want me to do it this way, and then I will run this, As you can see, it doesn't actually update the rectangle with the player's position, because I'm only making the instance of this class once here outside the while loop. If I put inside the while loop, that would technically work. However, the rest of the game won't really work, because I'm going to be making a new version of this. I'm going to make a new instance attribute every single time. So if I do something like this here, and then I run it, it's going to get a black screen with not much really working either. So that's why I made it work like that. So I'm just going to put this back down here, and after that, I'm going to get into this enemy ship movement. So here I got a bunch of other code which I was trying to make. This is previous failed attempts of me trying to make the enemy ship actually move properly. So here I'm checking if the enemy is off the screen. So if I go back to where I defined this enemy off screen variable, let's just quickly go up. Here, enemy off screen. So I put this to false. So if false means that the enemy is not off the screen. If the enemy off screen is going to be true, then that means the enemy is off the screen, and I want to do something about that. So I'm checking if the enemy is not off the screen. Then so when I start the game, the ship is actually starting here. So okay, let's see. Ship object has no attribute enemy wrecked. Okay, looks like I made a mistake here. Okay, that makes sense. So I was trying to draw the rectangle before I even made the variable for it. So here, so when I start the game, let's just quickly go back here. As you can see, the ship starts right here. So when it starts there, it's actually at the position Y1, and X is going to be 1 as well. So that way the enemy is not off the screen, it's actually on the screen, so it's visible to us. So I'm going to make it so that it's going to keep on updating the enemy's X position till it keeps on moving 1.3 pixels, whatever it was before I defined it here. So it keeps on moving 2 pixels across the screen. And then as well as this, I've also made it so that if the enemy is going to be touching the left side of the screen, so right here, if I open this up again, so if the enemy is touching this side of the screen, then it's gonna go back there, and then it's gonna keep on doing it that way. So I'm gonna show you guys how I did that. So if it's gonna be going there, then enemy off screen is gonna be true, so it's off the screen. And then here I'm checking if the enemy's screen is if the enemy is off the screen, then I want to make the enemy move backwards. So minus equals, I'm going to be subtracting from his x value. So when I'm doing plus, I keep adding to the x value, so it's going to be moving to the right. Whenever we do minus equals, it's going to be moving back. And then I'm checking if the enemy is going to be touching the first part of the screen here. So if I go back here, so I'm checking so the enemy's gone here. So I've checked if the enemy's gone here. I'm making it move back now. And then once the enemy has moved back here, I'm just going to check again if it's touching 0. Which 0, which is the origin point there of the if I visualize as a graph, that'd be the origin point. And then I'm going to be making so that the enemy off screen is going to be false, so it's going to run this one here again. And it keeps on doing that. I'm going to probably make it so it can go down as well. Then I'm just drawing this enemy method here, so just calling this other method here, draw the enemy, and then I'm calling this enemy draw ship movement here. And then as well as this, this is how I checked for collisions. So I'm just going to be checking, so there's going to be 2 objects which are colliding. So pygame.rect.collide rex, that's why I'm using a rectangle, so I can just check if both the rectangles are colliding. And if that's going to be true, that's going to print out collision has taken place and make a new line. I'm drawing the player using those 3 methods, and then I'm also making the player have a rectangle and drawing the rectangle of the player along with the player. I've also showed you guys how the rest of this is pretty simple. Here I'm just showing you guys how I detect for collisions. So I'm saying if the this part here has attributes, checking if the player rect has been so that whenever I have this player rect right here, if I go back here, okay, and so here I defined self.player rect, and then the thing is it won't actually work until I call that method. So it's not going to have this instance attribute called player rect until I call the method. So I'm checking if we do have both the player rect and the enemy rect, and then I just want to check for collisions between those two. And then if I go to the lasers section here, I'm also doing the same here. So I'm just calling super.collision because I've inherited from the ship class here, which also inherited from the main class, which gives me access to the instance attributes from the main class and the ship class. So I'm just calling all these different methods, and then I'm also just making a rectangle around the laser. Same top left, I made the color white. Then I'm calling the self.laser collision method, which is defined right here. And I'm just checking if the laser has a rectangle and there's also an enemy rectangle, and I'm just going to call this collision method from the from the parent class. You can also just replace this with self if you want to. This will still work because I call these methods up here, but I just want to call it by super because it makes it a bit easier for me to understand that this collision method has actually been defined in the parent class, not in this class. So that's it for today's video. I know this is quite a long video, but that's all I got up to. By the next video, I'm hoping that I've got a working system where I have the enemy moving across the screen, multiple enemies moving across the screen. They're going down, and then I can also check if I've hit the enemies with the laser. And I also have this empty method here called laser glow effect. I was planning to add a glow effect to the laser to make it look a bit cooler. I'm probably going to add that a bit later towards the end when I'm got pretty much everything else done in the game. And that's pretty much it. So I'd like to thank you for watching, and I hope you enjoyed the video. And I'll leave a link to the playlist containing all the videos in the description, because by the time you're watching this, there's probably another video which has come out. And yeah, you can watch that one if it just came out. So I appreciate it if you guys have subscribed to the channel and you like the video, and that's it for me today. Bye.